Alright, so I realized there was a little bit of confusion in the class on Thursday with these pulley problems and defining coordinate systems and pluses and minuses, and part of that is my fault for not being clear. So I made this little screencast to so hopefully clear up any kind of issues any of you had with these directions. Okay, so the first thing we're going to do is we've got this problem. So we've got a crate that's being lifted up this inclined plane at 4 feet per second by this motor here. And the question asks, at what speed does this rope have to be pulled up by this motor to lift this crate at 4 feet per second, considering you've got these two pulleys here. All right, so to do this, start with this problem, we're going to draw our datum line. And now we're going to define our coordinate system. And we're going to do this in two ways. I'll show you one way first, and I'll show you a second way. It gives you the same answer, and you can decide which way is easier, but I think knowing both ways will sort of help you conceptually understand this problem and these types of problems. Okay, so let's, we have this datum point here. We're going to call this the SA, and we're going to define everything this way as plus for SA. And we're going to define things in this way as minus for anything from this point, plus and minus. Okay? And now we're going to take now our second datum point right here. And so the SA will apply for these sections of the rope. And now we'll take this second point here, which we'll call P, and we're going to define now a coordinate system for this this section of the rope. And so now this SP section is going to be plus is going to be defined as this direction and minus this direction. So opposite of what we did for SA. And so now the total length of the rope is just going to be this section, which is SA. Then we have this section here, which is another SA, and this section here, which is another SA. So we have three SA. So SA plus SA plus SA. And now for this section, the section in red, which corresponds to this SP, we're going to call now that plus SP, because that section we'll say is in the plus direction this way for SP. So this gives you the total length of the rope, which is all the blue segments and all the red segments. And in this particular case, the SAs are all positive. So all of this is positive. This adds up to a total length of the rope. So DL dt is going to be 3 DSA dt plus DSP dt. And the length of the rope is not changing. So any length of the rope, as this pulley pulls up, it's just going to wrap the length around here. So these blue segments turn into red segments wrapped in that motor. And so this is just equal to 0, and you have 3 VA equals minus VP. And VA is the velocity this way, which is 4 feet per second in the minus direction. So this is a minus. So we have now 3 times minus 4 feet per second equals minus VP. And so VP equals plus 12 feet per second. And from this P point, we define the plus for this section to be in this direction. So the velocity of the cord, when this crate is moving up 4 feet per second, the velocity of this length of rope is upward at 4 feet per second. All right, so this way is you're basically taking this section and breaking it up and defining it along this SA coordinate, and then you're taking this section and defining it by this P coordinate. But now some of you might say, well, you know, it's kind of confusing. You have the same sort of line here, and in one section you're defining this as positive, and in this section you're defining the opposite direction as positive. Why don't we just make everything on this side of the line positive and everything on this side of the line negative? And that's what we're going to do, and I'll show you get the same exact answer. So let's now do that. So I'll get all this erased. All right. Okay, so again, now we're gonna draw this this datum line here through the middle, Now what we're going to do is we're going to say, okay, it's not a very good line. Let me do it a little bit better. Okay, still not perfect, but all right. So everything this way is positive, everything this way is minus. And so we're going to say, okay, this segments are SA. And again, similarly, we have this segments here. And we're going to now draw a second point here. We'll call this point P, and we'll say, okay, SP will be any sections. And again, for SP, from this point, this is positive, and this is minus. So we're going to be considered, this is positive for SA, this is minus. So now when we write the length, we have positive SA and positive SA defined from this point here. So that'll be SA, oh, let's make this, keep this black, SA plus SA. Now I left out this SA, so because now we have this sort of falls on the line of this P. So one way to think about it is you can say, okay, this is plus SA this way, we can add it here, and minus this segment, which was the SP segment here. So you can think this section here is this part of the rope, in black, I highlighted dark in black, that's this one, and these segments of the rope correspond to these. And so the reason it's SA minus SP is because the total length of this segment of the rope has to be, let me just kind of erase this, total segment of this section of the rope, so the SA minus the SP is written like this because basically SP in this case is a negative number because you're winding this rope, and so minus a minus gives you a plus. So that means the total length of the rope is going to be of SA, this segment, which is always positive, and this segment, which is always negative. So the total length has to always be positive. So that's why you have this SA minus SP, because SP in this case is now a negative number for any length of the rope on this side. All right, so now what we can do is we can take this is now L equals 3SA minus SP, where again the total length of the rope is 3 SA segments minus the SP segment, and because we defined anything on this side as negative, the minus SP is a negative number, so it's so L is a positive number for all potential SAs and SPs. So as the crate pulled all the way to the top, SA would be 0, and all SP would be a large negative number, which would mean the total length is just still a positive number. Okay. So now we take DL dt is equal to 3 dSA dt minus dSP dt. And this is going to be equal to 0 because the total length of the rope is not changing. Anything, again, that's being pulled up, losing this, anything lost here is going into the coil there. So 3 VA equals 3 VP. And now VA is in this direction, so it's equal to minus 4 feet per second. And so, sorry, this is should be here. Okay, so 3 VA is going to be VP, which is equal to minus 12 feet per second. And so now in this case, we're saying that the velocity that the rope is pulled up is in the minus direction, which we've defined everything in the minus direction to be this way. So the rope is pulled up with a velocity VP equals minus 12 feet per second, which is in this direction. So you get the same exact answer. And so hopefully after seeing it done both ways, you kind of understand the concept. And if there are any more questions, come to office hours. We've got office hours Monday to Thursday. Also give me feedback on whether you like these screencasts. I can do more of these. Yeah, let me know any feedback on the class. I look forward to hearing from you, and hope Hope you got some benefit out of this, and hope you have all a great weekend. All right, I'll see you in class on Tuesday. Bye-bye.